Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the Bragg's X-ray spectrometer. Okay, these are the parts. These are the procedures to be procedures how the X-ray are produced, right? X-ray generation and absorption. The Bragg's X-ray spectrometer. What is a Bragg's X-ray spectrometer? An X-ray diffraction experiment requires, as we saw previous video, we have seen the diffraction of X-rays using Bragg's law, right, where n lambda is equal to 2d sin theta is an equation for the Bragg's X-ray Bragg's law. The X-ray diffraction experiment requires X-ray source, the sample and a detector. Okay, for X-ray diffraction experiment we need X-ray source, the sample and a detector. Depending on the method, there can be variations in these requirements. Depending on the method what we are going to undergo, the variations in these requirements occurs. The X-ray radiation may either monochromatic or may have variable wavelength. Okay, the X-ray radiation can either have a same wavelength or a different variable wavelengths. Okay, structure of polycrystalline samples and single crystals can be studied. Structures of polycrystalline samples and single crystals can be studied. The detectors used in these experiments are photographic films. As we all know that the X-rays produced will be detected, will be found in a photographic film. We used to call it as X-ray, right? That is called a photographic film. What we need to perform a Bragg's X-ray spectrometer is that X-ray source is required, the sample is required and the detector is required. And the wavelength of the X-ray can be vary from a single wavelength to many wavelengths, right? The structure of polycrystalline samples and the single crystals can be studied. Okay, in this slide we can see that we have an X-ray tube. From the target point we have the lines, the X-rays are passing through the matched filters, and we have the collimators, and collimators are called the parallel beams, right? Collimators. And finally we have the crystals. From the crystal the rays are passing to the crystal, and from the crystal the X-rays are detected in a photographic film. We have a detector, right? That detector is called as photographic film. We hear from the X-rays are passed in a straight line, and once the X-rays touches the crystal, the rays deflect. That is called diffraction, 2d sin theta. We have the Bragg's law, right? That is 2 theta. The angle will be deflected. It will not go in a straight line. Okay, once the X-rays hit us a crystal or an object which is to be identified, the angle will be diffracted in a 2d sin theta angle. Okay, this is the schematic diagram of Bragg's X-ray spectrometer. The tube, we have tungsten filament. In the previous video we have seen the production of X-ray, how the X-rays are produced, right? This is a X-ray tube. We have tungsten filament cathode and an anode. This part is called as the X-ray produced, but it is called target. Once the electron beam hits the target, the X-rays are produced outside the tube. Okay, X-rays are produced outside the tube. Will have a matched filters where the X-rays by filtering the X-ray. We'll have many noises in that, right? By using filters, the X-rays can be filtered and the proper electron beam will be proper X-ray will be produced, and that by using that, once it hits the crystal or an object, it will deflect or deflect what the output to be measured in a detector. The detector is called photographic film. X-rays from the X-ray tube is collimated by passing them through slits S1 and S2, as I told you already. This beam is then allowed to fall on the crystal mounted on the table, which can be rotated about its axis perpendicular to the plane of incident of X-rays. How the X-rays are passed, right? The crystal plate, as we shown in this diagram, right? Crystal plates. This crystal plates can be rotated perpendicularly as the incident ray X-rays passes. The crystal behaves as a reflected grafting and reflects X-rays. By rotating the table, the glancing angle theta at which X-ray is incident on the crystal can be changed. As the table is rotated, the theta angle, right, that can also be changed. The experiment is repeated for each plane of the crystal. For the first order deflection, n is equal to 1, so that lambda is equal to 2d sin theta. For n, when n is equal to 2, we have 2 lambda, that is equal to 2d sin theta, and this goes on. Okay, this is the absorption, this is the Bragg's X-ray spectrometer experiment. How does it X-rays passes on the crystal and it is detected. Okay, thank you.